This is topic 8, video B. Let's practice. So we were given the following. Complete the table below for the lithium 2 plus cation with this incomplete table. And we know that in topic 8, we use the Rydberg equation, which is E equals negative 2.178 times 10 to the negative 18 joules times z squared over n squared, where z is the type of atom, the number of protons, and n is the subshell. So because we're going from an initial n to a final n, we use a modified version of this equation, which is n squared replaced by 1 over n final squared minus 1 over n initial squared, following the rules of PEMDAS. So for our first row, we know that our Z is equal to 3 because it's a lithium cation, and lithium has 3 protons. So we put all the numbers into the equation, where Z equals 3. The final n is 2. The initial n is 3. Then we multiply it, and then we put it into our calculator, and we get negative 2.7225 times 10 to the negative 18 joules. We know that this is energy released because delta E is negative, and it's going from a higher to a lower level. For the second row, again, we know that Z is equal to 3, and the final n is equal to 5, and the initial n is equal to 1. We multiply everything, and then we put it into our calculator, and we calculate that it's 18.8 times 10 to the negative 18 joules, and because we like to put it into scientific notation, it's the same thing as 1.88 times 10 to the negative 17 joules. We know that this is energy absorbed because it's going from a lower to a higher level. And delta E is a positive number.
For the next row, we are given the energy output and are to calculate the initial subshell. The energy output given is 1.74 times 10 to the negative 17 joules. This must be equated to negative 2.178 times 10 to the negative 18 times 3 squared being the number of protons for lithium times 1 over 3 squared minus 1 over x squared, x being the variable used for the initial subshell. By dividing 1.74 times 10 to the negative 17 by negative 2.178 times 10 to the negative 18 times 3 squared, we get negative 0.887664, that being equal to 1 over 3 squared minus 1 over x squared. Now we must add 1 over x squared to the other side and add 0.887664 to 1 over 3 squared. By adding 0.887664 to 1 over 3 squared, we get 0.9987756 equal to 1 over x squared. In order to get x squared by itself, we must multiply 0.9987756 times x squared and then divide 1 over 0.998776, giving us x squared equals to 1.001225, x equaling 1. Then we must take the square root in order to find x, which is 1.006. And as an approximation, we can say that x equals 1, and this means that the initial sublevel is 1. This means that energy is absorbed because we are going from a lower energy level to a higher energy level, and because our energy output is positive. Then we are given an energy output of negative 4.36 times 10 to the negative 18. When we equate this to negative 2.178 times 10 to the negative 18 times 3 squared times 1 over x squared, x being the final subshell that we are to find, minus 1 over 6 squared, 6 being the initial subshell, we get that we now need to divide negative 4.36 times 10 to the negative 18 by negative 2.178 times 10 to the negative 18th times 3 squared, which would give us 0.2224268, being equal to 1 over x squared minus 1 over 6 squared. Now, we must add 1 over 6 squared to 0.2224268 in order to isolate 1 over x squared. Then we must multiply 0.25020.406 times x squared, and then divide 1 by 0.25020.406 in order to isolate x. We must then take the square root of 0.25020406 in order to get x equals to 1.9991842, x being an approximate 2, meaning that the final subshell for this problem is 2. We then know that the energy is released because we are going from a higher energy level, 6, to a lower energy level, 2, and because our energy output is negative.